The assignment 9 talks about a major idea in statistics called regression or correlation. Now, the idea of correlation or regression, I'll tell you basically what it is before we do the question. Now, let's say you're trying to figure out if there is a linear relationship between hours of study per week and GPA. And then they tell you a student studies 7 hours a week, has a GPA 2.1. Someone studies 12 with a GPA 2.5. Someone studying 18 with a GPA 3. And someone studying 20 with a GPA 3.1. And then they tell you, can you figure out a relation? Can you predict someone's GPA from the number of hours? Is there a relationship between them? Since we're trying to predict GPA, whatever you're predicting, we call Y. And the thing that you're using to predict, we call it the predictor, we call it X. Is there a relationship between them? It's the, if you guys remember, it's the famous mx plus b, but in regression we call the relationship y equals b0, b1x, where b0 is your y-intercept and b1 is your slope. And let's say that you do the necessary calculation, you find y, GPA equals, say, when you do this, the B0 is 2, and your slope is 0.1 hours. So this is the relationship or the linear equation that relates hours to GPA. So if I ask you, can you predict someone's GPA, and that person studies, say, 10 hours, you plug 10, and that will tell you what the GPA is supposed to be. And how good this relationship is, you know this from the value of R. R is the coefficient of correlation, and it's going to be given in the question. This R is usually between -1 and 1. Now, it doesn't matter if it's negative positive, but the value is between -1 and of the value between 0 and 1. The closer the value to 1, the stronger the relationship. So if you get it to be 0.8, it's strong. 0.9, it's even stronger. Minus 0.9, also very strong, but negative. At 0.3, we consider this like weak relationship. Anything below 0.6, we consider this weak. I don't think you'll see the weak relationships, but that's what we consider weak. Okay, so when you open the assignment, the first 3 questions are just multiple choice. They tell you, first question, R, which is the coefficient of correlation, is used to determine, as we said, R is usually for how strong the relationship is. So it's for the strengths of the relationship. So it's the strengths of the linear relationship. Question 2 is, what would R squared be? So if you take this value of R and you square it, it gives you R squared, and that's coefficient of determination. This tells you that how close your observation to the regression line. So it's one of those definitions you need to know. So R squared tells you how close the observations or the numbers supposed to be to the least square regression line. So the answer would be least square regression line. And then they tell you if R squared is 1, and they give you possibilities. So you see this formula here? SSR over SST, sum squared residual over sum squared total. If R squared is 1, erase some of this. So if r squared is 1, so 1 equals SSR over SST. If we do the cross multiplication, then both are equal. And that's your answer. So your answer would be SSR must equal SST in this case. And then they ask you for a complete question. So here in this assignment, they tell you that you have two things. You have temperature and you have yield. And it's measured in grams. And they start when it's 100, 110, 120, 130, 140, 150, all the way to 190. They give you what the yield is. So in this version, it's 52.30, 69.95. For 120, it's 71.71. For 130, it's 86.28. For 140, 95.66. For 150, it's 105.18, and they tell you all the different numbers. Also, if you read the two lines after the table, they give you what R is. Coefficient of correlation, they tell you R is 0.9645 for this question, meaning the relationship between them is very, very strong. So you're trying to predict yield. So that's your Y, because we need to predict yield. And you're predicting yield from the temperature, so that's your X. That's your predictor. So temperature is X and the yield is your Y. So the first question, they want the average of temperature. So they want X bar. So I'm gonna add a section here for all the things we need to calculate. So the first thing they want you to calculate is X bar. So you know, you add them, you divide by how many there are. I think there are 10. If you do this, this gives you a 145. I did it earlier using Excel. So the average temperature is 145. Then they ask, what's the average? What's the mean for the yield? So they want Y bar now. Again, you add them, divide. I did that, and it's 92,252. Now they want the standard deviation for temperature. So they want the standard deviation for X. Again, like we did in this semester, there's a formula to do the standard deviation. So you take the numbers, you apply the formula for the standard deviation. I did it earlier, and it's 302765. You also want the standard deviation for the yield for Y. I did it, and it's 218793. Now they want you to test. Can you figure out the relationship? This is the relationship. Y yield equals B0, which is your y-intercept. This is your y-intercept. Plus B1 slope. X would be temperature. And this symbol E stands for the error, and it's usually 0. So to find this relationship, we need to find the slope. And that's what the question here. What is the slope? To do the slope, this is the formula we use to find the slope. We take the R, which is given, times standard deviation Y over standard deviation X. So 9645, standard deviation for Y is 21. and standard deviation for x is the 36.5. So I'm gonna do this in the calculator here. 9645 218793 over 32765, and the number would be 697. So the number here is 0697. I'll add it here. B1 slope is 697. Okay. To be able to use this formula, after finding slope, I need B0. There's also a formula for B0. This is the formula for the intercept. You take average y minus slope times average x. Both averages I have, so 92,252. Slope is 697, and my x bar is 145. So 92,252, 697 times 145. That gives me a B0 of minus 8813. So that would be my B0. So now I have the equation. Y hat equals B0 plus B1x. This is the general equation. So that means that yield equals B0 plus slope times x temperature. So this is the regression equation we're trying to establish that relates temperature to yield. Now the next question is, can you predict? Predict means use the equation. Can we use this equation to predict what the yield is when the temperature is 150? So we're predicting yield at temperature 150. So I need just to plug it into my formula. So minus 818, 697, and I put the 150, and that would tell me what the yield is, at predicted yield at this number. It would work out to 95737. This is your predicted value. The next question, what's your residual error for the temperature 150? You'll see in the given table, if you scroll up in your question, you'll see in the given table, you have temperature 50, and it has, this temperature has a certain yield of 105, which is different than this. The one in the table we call the actual. This is the actual yield. What we did the predicted yield. Residual, and that's what they're asking for, is the difference between the two. So your residual would be y actual minus y predicted. Actual minus predicted. So your actual is this. Your predicted is 95737. You do this, and it's 94430 for this question. Obviously, sometimes when you do this, the predicted could be more than the actual, so this residual could be negative. It depends on whether it's more or less, but in this case, your actual was more than the predicted, and the residual is positive. But it's okay if it's negative, that's what I mean. Now, they tell you, the last question here is, this is measured in grams. What if they do it in ounces? And to convert from grams to ounces, you need to multiply by, they tell you 3527. Okay, if you need to do this, would your slope change? Would this change, or intercept? Yeah. When you change the unit measurement, these two will change. And they will change by whatever the factor is. So if you need to switch from grams to ounces or whatever, you need to multiply this by the 3527 and you multiply this by the 3527. So B0, B1, they have to change. But your R, coefficient of correlation, it doesn't matter if you change or not change, if you go from any, this wouldn't change. It's just an indication of how strong the relationship, has nothing to do with the unit measurement, so it's not gonna change. So this wouldn't change, but of course slope or even the intercept will change according to whatever the factor is. This is it for the assignment. Now there will be another video for the tutorial. I'm also gonna see how can I help you with your final exam. I still haven't figured out how, but I'll know soon and I'll let you know. Good luck.